Chemical reactions and equations. Consider the following situations of daily life and think what happens when milk is left at room temperature during summers. An iron, tawa, pan, nail is left exposed to humid atmosphere. Grapes get fermented. Food is cooked. Food gets digested in our body. We respire. In all the above situations, the nature and the identify of the initial substance have somewhat changed. We have already learned about physical and chemical changes of matter in our previous classes. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. You may perhaps be wondering as to what is actually meant by a chemical reaction. How do we come to know that a chemical reaction has taken place? Let us perform some activities to find the answer of these questions. Activity number 1.1. Caution. This activity needs the teacher's assistance. It would be better if students wear suitable eyeglasses. Clean a magnesium ribbon about 3 or 4 centimeters long by rubbing it with sandpaper. Hold it with a pair of tongs. Burn it using a spirit lamp or burning and collect the ash so formed in a watch glass as shown figure 1.1. Figure 1.1 shown burning of a magnesium ribbon in air and collection of magnesium oxide in a watch glass. Burn the magnesium ribbon, keeping it away as far as possible from your eyes. What do you observe? You must have observed that magnesium ribbon burns with a dazzling white flame and change into white powder. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. Activity number 1.2. Take lead nitrate solution in a test tube. Add potassium iodide solution to this. What do you observe? In figure 1.2. Formation of hydrogen gas by the action of dilute sulfuric acid on zinc. Activity number 1.2. Take a few zinc granules in a conical flask on a test tube. Add this dilute hydrochloric acid or sulfuric acid to this. Figure number 1.2. Caution, handle the acid with care. Do you observe anything happening around the zinc granules? Touch the conical flask and test tube. Is there any change in its temperature? From the above three activities, we can say that any of the following observations helps us to determine whether a chemical reaction has taken place. Change in state, change in color, evolution of gas, change in temperature. As we observe the changes around us, we can see that there is a large variety of chemical reactions taking place around us. We will study about the various types of chemical reaction and their symbolic representation in this chapter. chemical equation. Activity 1.1 can be described as when a magnesium ribbon is burned in oxygen, it gets converted to magnesium oxide. This description of a chemical reaction in a sentence form is quite long. It can be written in a shorter form. The simplest way to do this is to write it in the form of a word equation. The word equation for the above reaction would be magnesium plus oxygen. Both are reactants of magnesium oxide. It's a product. The substance that undergo chemical change in the reaction 1.1, magnesium and oxygen both are reacts and change into magnesium oxide. The new substance is magnesium oxide formed during the reaction as a product. A word equation shown change of reactants to products through an arrow placed between them. The reactants are written on the left hand side with the plus sign between them. Similarly, products are written on the right hand side with the plus sign between them. The arrowhead points toward the products and shows the direction of the reaction. Writing a chemical equation. Is there one other shorter way for representing chemical equations? Chemical equations can be made more concise and useful if we use chemical formula instead of words. A chemical equation represents a chemical reaction. If you recall formulae of magnesium, oxygen and magnesium oxide, the above word equation can be written as Mg plus O2 MgO. Count and compare the number of atoms of each element on the LHS and RHS of the arrow. Is the number of atoms of each element the same of both the sides? If yes, then the equation is balanced. If not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Such a chemical equation is a skeleton chemical equation for a reaction. Equation is a skeleton chemical equation for the burning of magnesium in air. Balanced chemical equation. Recall the law of conservation of mass that you studied in class 9. Mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, the number of atoms of each element remain the same before and after a chemical reaction. Hence, we need to balance a skeleton chemical equation. Is the chemical equation balanced? Let us learn about balancing a chemical reaction step by step. The word equation for activity 1.3 may be represented as zinc plus sulfuric acid arrow zinc sulfate plus hydrogen. The above word equation may be represented by the following chemical reaction: Zn plus H2SO4 arrow ZnSO4 plus H2. Let us examine the number of atoms of different elements on the both side of the arrow. Firstly, element. Zinc, Zn, hydrogen, H, sulfur, S, oxygen, O. The number of atoms in reactants. Zn 1, H2, S1, O4. Number of products and number of atoms in products. RHS. Zn1, H2, S1, O4. As the number of atoms of each element is the same of both sides of the arrow. Equation 1.3 is a balanced chemical equation. Let us try to balance the following chemical equation. Fe plus H2SO4 arrow Fe2O4 plus H2. It's the equation number 1.4. Step 1. To balance the chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Step 2. List the number of atoms of different elements present in the unbalanced equation. Step 3. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or a product. In the compound, select the element which has the maximum number of atoms. Using these criteria, we select Fe3O4 that and the element oxygen in it. There are 4 atoms on the RHS and 1 on the LHS. Atoms of oxygen initially in the reactant, 1 in H2O, in product 4 in Fe3O4. To balance, 1 multiplied by 4 in the reactant, in products 4. To equalize the number of atoms, it must be remembered that we cannot alter the formulae of the compounds or elements involved in the reactions. For example, to balance oxygen atoms, we can put coefficient 4 as 4H2O and not H2O4 or H2O under the bracket 4. Now the partly balanced equation becomes Fe4H2O FeSO4H2. Fe and H atoms are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atoms in the partly balanced equation. To equalize the number of H atoms, make the number of molecules of hydrogen as 4 of RHS. Atoms of hydrogen initially in reactant 4 H2O. Okay. In products H2 2 hydrogen. 4 H2O in the reactant, it means 8 atoms of hydrogen. Okay. To balance, in reactants 8 atoms. In products, multiply by 4. 2 is multiplied by 4. The equation would be Fe4H2O arrow Fe3O4 plus 4H2. Partly balanced equation. Step 5. Examine the above equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, that is iron. Atom of iron initially in reactant is 1. In products, Fe are 3. Atoms of iron to be balanced, 1 in reactant, 1 multiplied by 3. To equalize iron, we take 3 atoms of iron on the LHS. 3Fe3 plus 4H2O arrow Fe3O4 plus O4H2. Step 6. Finally, to check the correction of the balanced equation, we count atoms of each element on both sides of the equations. The numbers of atoms of elements of both sides of equation are equal. This reaction is now balanced. This method of balancing chemical reaction equation is called hit and trial method. As we make trials to balance the equation by using the smallest whole number coefficient. Step 7. Writing symbols of physical states. Carefully examine the above balanced equation 1.9. Does the equation tell us anything about the physical state of each reactant and product? No information has been given in this equation about their physical states. To make a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formulae. The gaseous, liquid, aqueous, and solid states of reactants and products are represented by the notation G for gaseous, L for liquid, AQ for aqueous, S for solid, respectively. The word aqueous AQ is written if the reactant or products is present in the solution in water. The balanced equation 1.9 becomes 3FeS plus 4H2O arrow Fe3O4S plus 4H2G. Note that the symbol G is used with H2O to indicate that is this reaction water is used in the form of steam. Usually physical states are not included in the chemical equation unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and or below the arrow in the equation. For example, COG plus 2H2G 340 atm arrow CS3OHL 6CO2 aqueous plus 12H2O liquids in the presence of sunlight and chlorophyll, C6H12O6 aqueous glucose plus 6O2 aqueous plus 6H2O. It's equation number of 1.12. Using these steps, can you balanced equation 1.2 given in the text earlier. Types of reactions. We have learned in class 9 that during the chemical reaction, atoms of one element do not change into those of another element, nor do atoms disappear from the mixture or appear from elsewhere. Actually, chemical reactions involve the breaking and making of bonds between atoms to produce new substances. You will study about types of bonds formed between atoms in chapter 3 and 4. Combination reaction. Activity 1.4. Take a small amount of calcium oxide or quicklime in a beaker. Slowly add water to this. Touch the beaker as shown in figure 1.3. Do you feel any change in temperature? Figure 1.3 shown formation of slaked lime by the reaction of calcium oxide with water. Calcium oxide reacts vigorously with water to produce slaked lime, calcium hydroxide, releasing a large amount of heat. Calcium oxide solid quicklime plus water liquid arrow. Calcium hydroxide aqueous slaked lime plus heat. Equation number 1.13. In this reaction, calcium oxide of water combine to form a single product, calcium hydroxide. Such a reaction in which a single product is formed from two or more reactants is known as the combination reaction. A solution of slaked lime produced by the reaction 1.13 is used for whitewashing walls. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 or 3 days of whitewashing and gives a shiny finish to the wall. It is interesting to note that the chemical formula for marble is also calcium carbonate. Calcium hydroxide aqueous plus carbon dioxide gas arrow. Calcium carbonate solid plus water liquid. Let us discuss some more examples of combination reactions. Burning of coal, carbon solid plus oxygen gas arrow carbon dioxide gas. Formation of water from H2 gas plus O2 gas. 2H2 gas plus O2 gas arrow 2H2O liquid L. In simple language, we can say that when two or more substances, elements or compounds combine to form a single product, the reactions are called combination reaction. In activity 1.4, we also observe that a large amount of heat is evolved. This makes the reaction mixture warm. Reactions in which heat is released along with the formation of products are called exothermic chemical reaction. Other example of exothermic reactions are: first, burning of natural gas, methane plus 2O2 arrow CO2 plus 2H2O. Do you know that respiration is an exothermic process? We all know that we need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into simpler substances. For example, rice, potatoes, and bread contain carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cells of our body to provide energy. The special name of this reaction is respiration, the process of which you will study in chapter 6. C6H12O6 glucose aqueous plus 6O2 arrow 6O2 plus 6H2O plus energy. The decomposition of vegetable manure is to compost is also an example of exothermic. Identify the type of reaction taking place in activity 1.1 where heat is given out along with the formation of a single product.